Hi guys, these are our solutions to our first topic tests for our first year 12 advanced maths topic was graphs and equations without calculus. It was worth 26 marks. So here are my solutions. So I'm just going to split the first question up into two sections. I think overall we did pretty well in 1A, but what you need to remember when you're looking at inequalities, you need to think what an inequality does. The inequality takes away the negative part of the function that's inside that inequality. So we don't know if that original function, 2x minus 1, was giving us a positive value or a negative value. So we need to look at both the positive and the negative. Now, what I want you to do, I do not want you to put the negative sign in front of the 7 when we're doing the negative. I would like you to put the positive and the negative out the front of the absolute value, and we shall go from there. So looking at the positive, I'm going to be looking at positive 2x minus 1 is greater than or equal to 7, and negative 2x minus 1 is greater than or equal to 7. Rearranging our first one, I'm going to be adding 1 to both sides, so I get 2x is greater than or equal to 8, and I'm going to divide by 2. X is going to be greater than or equal to 4. I do not need to flip the inequality sign because I'm not dividing by a negative. 2 is positive, so that is my first solution. X is greater than 4. The second one here, I'm going to multiply out my negatives. Okay, I'm going to take 1 from both sides, so I'll end up with 2x is greater than or equal to 6. Again, I'm not flipping the negative sign because I'm only taking away 1. I'm not adding or dividing by a negative. What I will need to do on the next step, though, is because I am dividing by a negative 2 here, I'm going to divide both sides by that negative 2. My inequality now does need to flip, and that's where a lot of people went wrong on that question. So they're my two solutions for number 1. I just want to show you something. I mentioned on the negative side over here that I want you to put your negative in front of the function, or the part that is inside the absolute value signs, not in front of the 7. I'm going to show you why as a little aside down here. So let's just say we were doing the negative and we went 2x minus 1 is greater than or equal to, and I put my minus 7 on the other side. Let's say I did that. Now I'm going to add 1 to both sides. I'm going to end up with 2x is going to be greater than or equal to minus 6. And divide by my 2, I get x is greater than or equal to minus 3. These are different. Okay? So and this will happen sometimes. So the answer I've got up here is the correct answer. So I would like you to just pay attention and make sure that you don't pop that negative in front of the 7. If you do, you need to think about what you're doing. Okay, because it's going to affect your answer a little bit. So let's just stick it to doing it the way that I've got up above, and then we'll be happy with our answers all the time. Okay, let's look at the second one. Okay, there was a little bit of confusion in this, which the way that it typed up, if you've gone and popped brackets in there and solved it, I've marked your answer correct. But I actually wanted it done with absolute values. So the solution I'm going to do is going to have absolute values in it. And I think that's going to be a good practice for you. So I'm going to split this into 2. I'm going to have 2 less than the absolute value of 3x minus 1. And I'm also going to have the absolute value of 3x minus 1 is less than or equal to 11. And what we're going to end up with is 2 solutions on this side and 2 solutions on this side as well, because I'm going to need to look at the positive and the negative value over here. So I'm going to write positive and negative, and positive and negative. Because there's an absolute value, that's what I need to do. So looking at the positive value, 2 is less than 3x minus 1, and 2 is less than minus 3x minus 1. So let's solve this hand side first. Let's add 1 to both sides. So what I'll end up with is 3 is less than 3x, and 1 is less than x. I'm not having to divide or multiply by negative, so the answer is not needing to have the sign flipped. On this side, 2 is less than. Let's expand that negative sign out, so I end up with minus 3x plus 1. Now let's take 1 from both sides, so I'll end up with 1 is less than minus 3x. And now I need to divide by that minus 3 to get x by itself, and it's going to flip my inequality sign. So I'm going to get minus a third is greater than or equal to x. They're my 2 solutions for this side of the equation. There's also 2 more solutions on the other side, positive and negative. 3x minus 1 is less than 11, and minus 3x minus 1. Oops. Fix that bracket up, is less than 11. Oops, we've lost it there. Back up here. Just slide my OneNote over a little bit. Okay, so solving this one, 3x is going to be less than, adding 1 to both sides, we're going to end up with 2, and x, oh, it's not 2, because that was 11, wasn't it? Sorry. We're going to be ending up with 12, and then we're going to end up with x is less than or equal to 4. There's my first solution. Multiply out the -1, so I'll end up with minus 3x plus 1 is less than 11. Let's take 1 from both sides. We're not doing anything with our brackets because, with our inequalities, because we're not dividing or multiplying by a negative until now. Now I'm going to divide by -3. I need to flip that sign. So x is going to be greater than minus 10 on 3. There are my 4 solutions. And that's what I was after. But if you actually saw my sign and it looked a little bit strange, I have fixed that up in your marking. We've got f of x is x squared plus 1, g of x is x minus 1. Find g of f of x. A nice, simple question. G of f of x is g of, well, my f of x is x squared plus 1. So that's what I'm doing first. G of x squared plus 1. But I currently have g of x, so wherever I have an x, I'm going to replace it by x squared plus 1. Here's an x, I'm going to write x squared plus 1 where that is, and I also have a minus 1. So my answer is x squared. Overall, that was done pretty well. If not, you need to go back and look at functions of a function. Okay, question 3 here. Surprisingly, I was not happy with how this was done. A lot of people did not draw a graph and therefore got the wrong intervals for our solution. So it's saying solve x squared plus 3x plus 2 is less than or equal to 0. Write your answer in interval notation and bracket notation. You guys didn't have a problem with the interval notation and bracket notation. You just got the wrong intervals or notation for the question because you didn't do what you needed to do. So step 1, I need to draw this graph. I need to find where this graph actually is less than or equal to 0. And you cannot do that unless you're very cluey without drawing the graph. I like to draw the graph and I would encourage you to. So otherwise we're assuming a lot. So we're looking at factorizing, adding to 3, multiplying to 2. If I factorize that, what am I going to end up with? I'm going to end up with a plus 2 and a plus 1. And I want to find where that is less than or equal to 0. My zeros for my graph are going to be at minus 2 and minus 1. So it's just a quick sketch. You're not having to draw it in any great detail. I don't want your y and x intercepts at this point. All I want is a graph that shows me that it looks like this. Where is this graph less than or equal to 0? It is less than or equal to 0 in that range there. And this is what people were doing. They were guessing that that was the interval. And sometimes you guys guessed right, which was good, but quite lucky. So the range that I want, where it is less than or equal to 0, is minus 2 is less than or equal to x is less than or equal to minus 1. So in that domain is where our graph sits below the x-axis. Writing that in bracket notation, because it said interval notation and bracket notation, I wanted to see minus 2, minus 1 in square brackets. Okay, let's go to the next one. Number 4, write the new equation for the function below after the given translations have been applied. Here's our function, x squared minus 3. We're going to shift it right 3 units, and then we're going to shift it down 2 units. If I'm shifting it right 3 units, then my x is going to become x minus 3. That's my first part. And then I'm going to shift it down 2 by y is going to, we're going to take 2 away from y. Let's do it. So to start with, my y becomes x minus 3 or squared minus 3. And you can, a lot of people factorize that. Not factorize it, expanded that then. You can expand it then. I'm going to actually now pop in the down 2 units as well. So it's going to become x minus 3 all squared. I'm going to subtract 2 more units from that. So I'll end up with minus 5. You can leave it like that, or you might have written it in the expanded form and collected like terms, which would have ended up with x squared minus 6x plus 4. But I was happy with either one of those, but you needed to have both of those in there. Okay, so this one wasn't done too badly, but people are starting to not put their working out down at this point. So let's put everything you're thinking down on paper. So write down the new function when each dilation is applied to the parabola y equals x squared minus 2. Then sketch the curves. I'm going to do it the way that I wanted it done. A couple of people did it slightly different. That also was okay, but this is what I was after. Okay, so the first thing that we did to that curve was we did a horizontal dilation of a factor of a half. So x is going to become x over a half, which if we flip that half around becomes 2x. So I wanted to replace my x by 2x, and then I will replace my y by minus y. So number 1, x goes to 2x. So my function, wherever there was an x, you put a 2x, and you square the whole lot, not just the x. So I'll end up with 4x squared minus 2. There's my first part. Now, a lot of people went and then added a minus dilation to that. That's fine. I wasn't after that because it says write down the new function when each dilation is applied to the original function. But it still showed me that you knew what you were doing. So if you applied the minus dilation in the vertical to this function, I was okay with that for here. But I wanted y being our original function. So that's what I'm going to show. So here we're going to have now y is minus x squared minus 2. So it's minus the whole lot of that function because that's what's happening. So I'll end up with minus x squared plus 2. Now you wanted to draw those for me on here. So our first parabola, well, this is our second parabola actually, minus x squared plus 2 would have gone through 2, and it would have gone through minus root 2 and root 2. Our second parabola was a happy parabola. It was a positive parabola, and it's going to go through minus 2. It's a little bit skinnier because it's got 4 out the front. It's going to look like this, and it's gone through minus a half and a half. And that's all you need to do for that one. Okay, let's go to the next one. Okay, this was a fairly full-on question. It was worth 5 marks. Overall, this was done really well. I still think some of you need to go away and practice what we did in class, because when we got into it, you didn't do the sign and look at x and y and sign, and a lot of you didn't look what happened near the asymptote. If you didn't do that, your graphs probably didn't turn out too well. A lot of people forgot to take the positive and the negative when you square rooted the function. And there was a few people who showed no working out at all. So I need to see the working out in order to get you those marks. So let's pop these answers down the side. Identify the domain of x. The domain and the vertical asymptotes are pretty much the same thing. When we're working out the domain, we're going to find the vertical asymptotes. And you're looking at the bottom line where we can't divide by 0. So 4 minus x squared can't equal 0. It's a difference of 2 squares, or you might have taken your 4 over to the other side. I'm going to write it as the difference of 2 squares. So x can't equal plus 1 minus 2. So our domain is going to be all real x except x is not equal to plus 1 minus 2. Part 2. Identify the vertical and horizontal asymptotes. So our vertical asymptotes are our x1s. So we've just found those up here. So vertical asymptotes at x is plus or minus 2. Again, you needed to have the plus and the minus. A lot of people forgot what we were doing. If you didn't get this difference of 2 squares up there, and you might have written it as 4 equals x squared and then taken the square root of 4, you need to take the plus or minus, okay? And that got a lot of graphs incorrect because you didn't get that negative asymptote in there. That vertical asymptotes are done. The horizontal asymptotes. Now, a lot of people did this really well. If you did, good job. If you didn't, you need to go back and have a look at what it means to find a horizontal asymptote. To do that, we need to have a look at the denominator, look at the power of the highest x, and it's a 2. And what we need to do is divide through by everything by that x squared. So what my top line, so I'll just zoom down there a little bit so I can see it, is going to become, I'm going to have on the top line x divided by x squared, and on my bottom line, I'm going to have 4 over x squared minus x squared over x squared. So note every term is divided by that highest power from the denominator. My top line becomes 1 over x. My bottom line becomes 4 over x squared minus 1. Now what we want to look at, as x goes to infinity, what does y do? As x gets really, really big, the number on the top there goes towards 0. It gets really, really small, and my bottom becomes 0 minus 1. So I will end up with a vertical asymptote of y equals 0. We're nearly there. Identify any asymptotes. So we're looking at where it cuts the x-axis. This is the old-fashioned way you guys did in junior school at y equals 0. And that will give us x equals 0. And it cuts the y-axis at x equals 0, and we will get y equals 0. So you need to go and make sure that you can do those and get those two values. So it's going to cut at 0 and 0. We've done all those in class. Now, we needed to have a look at the symmetry of the function. Overall, this was done pretty well. Some people forgot what the rules were. So if we're looking at f of minus x, if that equals f of x, it's even. If f of minus x is equal to minus f of x, then it is odd. If it's not either of those, it's neither. So my suggestion is to put f of minus x in there, or put minus x in the function, and see what we end up with. And that will easily test for us in one step. So f of minus x is going to be equal to minus x over 4 minus x squared. Top line stays minus x. Bottom line, the 4 and the minus are there, but when I square anything, that becomes x squared. So what I now have got is I have got that equal to minus f of x. Okay, so it's my original function. It's just got an extra minus in there. Bottom line's the same. So that's an odd function. Okay, and now I need to sketch it. I might just go over to the next page to sketch that. I'll scroll down a little bit. Okay, now what you will find is you probably don't have enough information yet to sketch it. You would be guessing it, and that's what a lot of people did at this point. So let's see. What do I know? I know it cuts here. I know I've got an asymptote at plus and minus 2. I know I have a horizontal asymptote here at y equals 0. That's all I know right now, which is a lot of stuff, but I don't know anything. Oh, and I know it's odd. So I really need to have a look at what happens on one side, and then I can repeat it on the other side. So we might have a look at that. What you need to do, though, there's still more information, and even though the question hasn't asked you to do this, you can't answer the question without doing this. So we need to look at the sign, and then we might need to have a look at what happens as x gets to 2 from the negative direction, and as x goes to 2 from the positive direction. We can look at that with minus and positive, with minus 2 as well. But because it's odd, if we just look at it in this one part of our graph, we can mirror it over the other side because that's what the odd function is telling us. Now, if I'm having a look at the sign of the graph, what I want to do is have a look around my x-intercepts, which was 0, and my vertical and my horizontal asymptotes. Sorry, not my horizontal, just my vertical. So we know that 0, 0, 0 is there. There's no sign because it goes through 0. At 2, it's an asymptote. I don't have any sign because it doesn't touch. So what I need to do is have a look at values between those. Let's find 1 and let's find minus 1 and see what happens. And I forgot, I'm also going to need another number. I need a 3 and a minus 3. See if we can squish that in there first. So let's have a look. So if I am to put 3 into my function, we might just quickly write our function down here again so we can see it. We've got y is x on 4 minus x squared. So if I pop 3 into this function, I'm going to end up with a 3 over a 4 minus a 9. I'm going to get a negative number. So I know that over here at 3, I'm negative. My function's negative. It's down there somewhere. When I look at 1, I put 1 in here. I'm going to end up with 1 on a 4 minus 1. It's a quarter. It's still positive. It's a small number, but I'm going to end up here. Then we know we're going to hit 0 at 0, and at minus 1, what am I going to end up with? I'm going to end up with minus 1 over 4 minus 1. I'm going to be negative. So straight up, I can see my graph's going to go, it's going to be here, it's going to be here. Chances are, it's not a straight line. Chances are it's going to be a cubic, and we can test that later on. Looking at minus 2 is an asymptote, so it doesn't touch. So we need to look at the other side and see what's happening down here at minus 3. If I pop minus 3 in my function, I get minus 3 on 4 minus, what do we got? 4 minus 9. I'm going to get a negative on the top, and the bottom I'm going to be positive. So that's positive. So we've got a positive there, we had a negative there, we had a positive there, and a negative there. So I'm up here. So I'm not in this quadrant and I'm not in this quadrant. So if you did not use this rule or you didn't use it properly, or you didn't put your values in properly, you're going to have had your graphs up here possibly. Okay. Now, I know now my graph what it looks like, but if you don't, you need to look at what happens here. And what that says is, what happens to our graph as x gets close to the asymptote from each side? So if I'm looking at approaching 2 from the negative side, I want a number that's really, really close to 2. If you can't visualize it, we're going to pop a number in. Maybe you're going to pop in 1.99999. If I pop that into my function, what I'm going to find is I'm going to get a number that is, what are we going to have? 1.99 on the top, 4 minus 1.999 on the top. I'm going to get a positive number, but it's going to be pretty small. So I'm going to shoot off up there like that. If I'm looking at approaching it from the other side, over here, so just over 2, so a number that's like 2.00001, if I put that into the function, I'm going to get that on the top, 2.0001, but on the bottom, I'm going to have 4 minus a number that's bigger than 4. So when I square it, 4 minus a number that's bigger than it, I'm going to get negative. So what happens at this side of 2, it shoots off the other direction. Okay, so you kind of need to test at each point what is happening to know where your graph's going to go. Now, I know there's an asymptote here and it's going to skim it. I'm going to go like that. And I know here, I'm up. I'm going to go here. I need to go here. Now, you can now test what happens as you get closer to either side of the -2 asymptote. Or you can look at this graph and use the information where you know it's odd. And what does an odd do? An odd's going to reflect it about the x-axis. So my graph's going down here and my graph's going up here. And that's what our function looked like. Okay. Overall, you guys did pretty well on this one, but a lot of you didn't read the question. And it said, and this is our first, we only really did this in class the other day, so good work. It said explain. Explain means you need to use words. Explain the way the function y equals 2 lots of sine 3x plus pi on 6 plus 1. Explain the way that function is obtained from y equals sine x using a sequence of translations and dilations. So explain how I got from this to this using these. So you need words to start with, and then you can tell me what the period, the phase, the amplitude, and the mean are. A lot of people just did the period, phase, amplitude, and mean. You got marks. I wanted to see your explanation, and it didn't ask me to draw a graph. So don't draw me a graph. You don't need to. Unless you want to, you don't need to, and it's just going to waste your time. So what I was looking at for my explanation is just something simple. We're going to start with y equals sine x. So I want to see these things. I want to see that we move pi on 6 units to the left. I want to see you write that. That's the phase. A lot of you wrote that. That's great too. You need to have both of them. Phase is pi on 6, okay? These things tell me the same thing, but I need to know that you know what the phase is as well, and that's what that question wants you to find out. Now, we're going to look at a horizontal dilation. Now, this is going to really see if we know what we're talking about. A horizontal dilation of 1/3. That's where this 3 comes from. So what's happened is x has gone to x over 1/3, which gives me 3x. Okay, that gives me my period. That 3 as well. So a lot of you missed this part. You don't need to write this bit in, but you need that sentence. The period, originally sine has a period of 2 pi. We've changed it by a factor of 3, and that's where that 3 comes from. Okay, that 1/3. That 3 goes on the bottom. And next part, we are going to do a vertical dilation. This is the easy one, 2. So basically y is going to y over 2. That's where that 2 goes from there. And that's going to give us our amplitude. Some people are writing A for amplitude. No, we're not writing A for amplitude. We're just going to write amplitude. Okay, and our last one is we're going to translate up 1 unit. That gives us something else as well. That changes our mean. So our mean goes to 1. Okay, normally our mean is 0 on sine x. We've shuffled it up to 1. Everything oscillates between 1. That's our mean. You need to have all of those things in there, okay, to get you full marks on that question. Let's look at the next one. The next one was done really well. Good job. You guys were great at graphing this. Below is a diagram of an unknown function p of x. I think everyone got this out. Mostly. 99% of us got this one out, which was great. We want to draw the functions p of x minus 1 and draw the functions of p of x, then take off 1. So p of x minus 1 we know goes right 1 unit, and p of x minus 1 goes down 1 unit. So you just needed to draw the graphs. I move this one right 1 unit. I'm going to cut through here. It's going to look like that. That's my p of x minus 1. Just change colours. If it's p of x minus 1, the whole thing's going to shuffle down. So I'm going to go down to minus 1 unit, and everything's going to translate down a little bit. And I'm not really great at drawing that here, but that's what it's going to look like that. And that's what you needed for those graphs there. Nice easy marks. Let's go over to the next page. Okay. Let's look at our asymptotes. Overall, I think this was done pretty good. You just need to remember how to do your horizontal asymptotes because they're the harder ones, I think. Now, we look for the highest power of the denominator on our function. Okay, it's x squared. So we want to divide everything by x squared. The top line, I'll do it the long way, x squared on x squared plus 5x on x squared plus 6 on x squared is our top line. Our bottom line becomes x squared on x squared. I know it's tedious. 4x on x squared plus 3 on x squared. As you get better at this, you'll be able to skip this step and go straight to the next step and see, okay, x squared on x squared is 1 plus 5 over x plus 6 over x squared. Maybe you're good enough to do that now. 1 minus 4 over x plus 3 over x squared. We want to see what happens as x goes to infinity, or x gets really, really large. As x gets really, really large, what does y do? On the top line, y goes to 1 plus 0 plus 0. Remembering, when x gets really, really large, 5 over x gets really close to 0. So we're going to look at the limit. Remember, we're looking at the limit as x goes to infinity of 1 over x, and we know that that's 0. And that's what we're doing for each of these terms. The same happens to the bottom. It's y minus 0 plus 0. So y is going to 1. So y equals 1 is a horizontal asymptote. And that's how we find them. Different down here, we can easily see what the asymptote's going to be here. Here we can't. We need to work it out. And you might need to work it out below anyway. Vertical asymptotes. Okay, these are the ones you looked at in year 11 and you might have looked at in year 10. We can't divide by 0. So our vertical asymptotes are x equal to something. So we need to look at where that bottom line can't equal 0. So x squared minus 4x plus 3 cannot equal 0. Let's factorize that bottom line. What do we get? We're going to add to minus 4. We're going to multiply to 3. What are we going to have? We're going to have minus 3 and minus 1, giving us x cannot equal 3 and x cannot equal 1. So our vertical asymptotes, oops, let's go short for asymptotes here, at x equals 3 and x equals 1. I didn't ask you to draw that graph, but we could also draw that graph. That would not be a very nice one to draw, I don't think. Okay, now sketch the graph of y equals 1 plus 3 over x squared. Yes, you need to sketch it, but you need to do some work in order to sketch it. So step 1 is let's find the asymptotes. X minus 2 cannot equal 0. X cannot equal 2. I would straight up go and draw that in. There's my first asymptote, vertical asymptote. Y up there. Now looking at that graph, you should feel fairly comfortable after the amount of graphs that we've done that it's a hyperbola. So remember, y equals 1 over x is a hyperbola. We've got y equals 3 over x minus 2. It's a hyperbola that is translated to the right by 2, and it's shuffled up by 1. So up 1, right 2, and we have a little bit of a dilation in there as well by a factor of 3. So before you even draw that, we should be confident that that's what the graph is. And if you've drawn something else, then you haven't got the right graph. So what we're going to have is we're going to have a horizontal asymptote. We've already looked at the verticals. So when we were doing our work in class on these, I got us to combine these as one term. If you had have done that, that would have worked lovely. But what we're actually doing, because we're moving up by 1, we can straight up say that we have a horizontal asymptote at y equals 1. Now that we've done all the translations, we can see that. And we kind of just need to look at, well, is it an odd or we know it's an odd function, but which quadrants are we in? So we're either going to be here and here, or we're going to be here and here. Where are we going to be? You need to check the sign of your function, okay? It's not going to have x-intercept, or you could maybe find your y-intercept. That might help you as well. Let's try that first. Our y-intercept happens when x is equal to 0. What are we going to have? Our y is going to be 1 plus 3 over minus 2. So what have we got? Will give us 1 minus 3 over 2, which is 1.5. So we're taking away more than we've got. So we are going to be having our value down here. We're cutting at the bottom. So straight up, that's where our graph's going to go. If you're not happy about that, what we can also look at, oops, I've just shuffled my page around there, is the sign of our function. So x, y, and sine. And if you pop in your values of, what have we got? We've got 2 as our asymptote. We pop that in and we have a look at values either side of it. We could have found where it cut the x-axis as well, which it actually does. I found that it cuts the x-axis at -1. We didn't do that though. Maybe we should do that as well. Sorry, I'm just assuming because it's a fairly easy graph. X-intercept at y equals 0. I'll just shuffle that up. Just going to fix this page up a little bit. It's slid down. There we go. So what we will have is 0 equals 1 plus 3 over x minus 2. So what we will end up is, where are we? -1 equals 3 over x minus 2. We keep going, we're going to get times these guys together. Minus x plus 2 equals 3. Minus x is going to be equal to, it's a bit squishy here, 1. So x is going to be equal to -1. That's where I got that from. So we're going to cut here. So there's 2 bits of information that are telling us, but if we check the sign of the function, that will help us as well. But our graph is going to look like, mine's not beautiful here. That's where it goes, and that's what it's going to look like. I'll just fix this up down here a little bit. Sorry, that's a very wobbly graph there, but you get the idea of where I'm at. It's a bit hard on the OneNote to draw this. But again, the sign of the value. If you had have done that sign of the value, and let's grab another colour, that would have also helped you out. So we would have looked at values either side of here. So we would have popped in a 0. We would have also popped in, say, 3, and we would have popped in -2. We would have got a positive, a negative, and a positive. But you get the idea of where we're at. So you kind of need to look at all those things. And then if you were at a point where you didn't know what was happening, you could have also had a look what was happening around the asymptote x equals 1. So you might say, well, what happens is x goes to 1 from the negative side and x goes to 1 from the positive side. So as we approach here and here, we would have found as we're approaching 1 from the positive side, we would have shot up to infinity, and as we approached 1 from the negative side, we would have gone down to negative infinity. So we could have looked at all of those, and they're all the things that we can have a look at as the graphs gets harder. And that's the end. Thanks, guys.